Good. So I will be screenshotting and bringing things inside of the document. So we wouldn't have the whole document for this one, right? So number 1, solve the equation 3 to the power 2x plus 1 take away 5 into 3 to the x take away 2 is equal to 0. Now from the time you see something looking like this business going on here, you know it's some kind of substitution we have to make. So first thing I'm going to do, I know this is going to be my substitution because I cannot change how this whole thing here looks. And this is the exponential part. So I'll change how this looks. This is going to be, I'm going to consider 3 to the power of 2x plus 1. This is equal to 3 to the power 2x multiplied by 3 to the power 1, which is equal to 3 to the power x squared multiplied by 3. So we're good to go. So therefore, I'm going to have an equation that looks like 3 into 3 to the power x all squared take away 5 into 3 to the power x minus 2 is equal to 0. Now, if you're good and it's a boss, you can go ahead and see the quadratic over here. This is a quadratic in terms of 3 to the power of x. You could use quadratic formula and say, since the variable you're solving for is 3 to the power of x is equal to minus b plus or minus square root b squared minus 4ac all over 2a, or if you're real comfortable, you could go ahead and factorize this. But just for the visual preference, we go let me let a be equal to 3 to the power x. So I'm going to get 3a squared take away 5a minus 2 is equal to 0. I'm going to get 3a squared. I'm looking at minus 6 and 1 minus 6a plus a minus 2 is equal to 0. Now I'm going to get 3a into a minus 2 plus 1 into a minus 2 is 0. I'm going to get a minus 2 into 3a plus 1 is 0. A is 2, or a is negative a third. From here, go upstairs here, I'm going to say recall a is 3 to the x. So I'm going to get 3 to the x is equal to 2. Can't change, so I'll take ln on both sides. And all you know me, I like ln already. ln 3 to the x is equal to ln 2. I'll recall again. Well, I have a recall lying above, so I will just put a new recall line, man. That is small thing. Recall the law of logs that says if I have log of a to the power c to base b, this law works both ways. That is why we have the double arrow. It's c log of a to base b. I'm going to have x ln 3 is ln 2. X is equal to ln 2 divided by ln 3. And the question did ask for the answer to be to 3 decimal places. This is equal to, jump on the calculator, ln 2 divided by ln 3. The 3 decimal places is 0.631. 0.631 to 3 decimal places. But remember, we have the next piece as well. Or 3 to the power x is equal to minus a third. Again, I'll take ln on both sides. Now, while I might say, well, you know, sir, you could have bring that 1/3 as 3 to the minus 1. You could, if I do that, right? 3 to the x is negative 3 to the minus 1. This base is 3. This base is negative 3. And I don't really have no work around it. So we'll have to take logs. ln 3 to the x is ln of minus a third. And this here is not possible since, and I'll recall, if log of a to base b is equal to c, both a and b must be greater than 0. This here is the reason it's not possible. All right, so that's one part A, 5 marks. Next, B part 1. Given that 3x plus 2 is a factor, find the value of b. Now, if 3x plus 2 is a factor, we do have the name of the function, so I'm going to let f of x be equal to 3x cubed plus bx squared minus 3x minus 2. So, f of x divided by 3x plus 2 is equal to f of negative 2/3. And this is equal to 0, since 3x plus 2 is a factor. Now, I'm using the factor theorem, so I'll recall the remain non-factor theorem. So I'll recall, if any polynomial f of x is divided by x minus a, the remainder is f of a. If f of a is equal to 0, then x minus a is a factor of f of x. So now I'm going to let f of negative 2/3 be equal to 0. 3 into minus 2/3 cubed plus b into minus 2/3 squared minus 3 into minus 2/3 minus 2 is equal to 0. Well, you have your calculator, and if you're real comfortable with your calculators, you can go ahead and work out all the constants on the left-hand side. So let me take it step by step. Let me go with 3 into negative 2/3 cubed. I'm leaving it as a fraction. That is minus 8 over 9 plus b into 4 over 9. Then I'm going to have minus 3 into minus 2/3. That's just going to give me 2. So I'll get plus 2 minus 2 is equal to 0. Rearrange, I'll get 4 nines b. 4 over 9b is equal to, move it across, I'll get 8 over 9. Multiply both sides by 9, I'll get 4b is equal to 8. Divide both sides by 4, I'm going to get b is equal to 2. And we're good to go. So we found the value of b. Hence, factorize completely the function. All right, no scene. Hence, factorize completely this fella here. Now, it have a work around these types of questions as long as you write your statements properly. So now I can say, what do you work around, right? Therefore, f of x is equal to 3x cubed plus 2x squared minus 3x minus 2. I know one factor is 3x plus 2, but I could also get the other factors from my calculator. I can say, since f of x divided by 3x plus 2 is equal to 0, I can say that 3x plus 2 is a factor of f of x, and we did that above. I can also say that f of x divided by, I can go on my calculator for those who have a calculator that could solve a cubic. A is 3, b is 2, C is negative 3, and D is negative 2. Minus 1 is an answer. If minus 1 is an answer, then x plus 1 is a factor. This is f of minus 1, which is equal to 3 into minus 1 cubed. And this is a workaround, right? Plus 2 into minus 1 squared minus 3 into minus 1 minus 2. Bet your bottom dollar again 0. I'll get minus 3 plus 2 is 5. 5 minus 3 by that, minus 3 plus 2 is minus 1. Minus 1 plus 3 is 2. 2 minus 2 is 0. And then I can now say, therefore, x plus 1 is a factor of f of x. Our next answer is 1. So I can now come and say, well, f of x over x minus 1 is equal to f of 1, which is 3 into 1 cubed plus 2 into 1 squared minus 3 into 1 minus 2. This is also 0. Therefore, x minus 1 is a factor of f of x. And now I get my 3 factors by using my calculator and writing down my statements very, very smartly. I can say f of x is equal to 3x plus 2 into x plus 1 into x minus 1. Now, if I go back on my calculator and I press equal again, I'm going to get this answer here. This answer will be negative 2/3, which is going to be negative 0.66666 minus 0.6666666 going down the road. Now, the long way around this, and I'll do a little or here. It have 2 ways to do it. One way is by long division. The next way is by comparing coefficients. So generally, a linear 3x plus 2 multiplied by a quadratic ax squared plus bx plus c supposed to give me the polynomial in question, which is 3x cubed plus b x squared minus 3x minus 2. So my x cube coefficient, if I say compare coefficients, my x cubed coefficient, I'm going to have the only x cubed coefficient I'm going to have is when I have 3x by the x squared, I'm going to have 3x cubed. So my coefficient on the left is 3 is equal to my 3a. My coefficient on the right is 3, and I can calculate the value of a. A is 1, no c. Now I'm going to compare my constant because those are the 2 easiest things to get. 2 multiplied by c is going to give me my constant is equal to negative 2, and I'm going to get c is minus 1. Now I could calculate my x squared coefficient. The only way I can get an x squared is if I have 2 multiplied by a x squared, which is going to give me 2a, and then 3x multiplied by bx, which is going to give me 3b. 2a plus 3b is equal to, my x squared coefficient would have been 2 in the first place. I know what a is. A is 1. 3b is equal to 2. Take away 2 into 1. 3b is equal to 0. And b is equal to 0. So therefore, the quadratic going on b, ax squared plus bx plus c is equal to, a is 1, x squared, c is minus 1. And this is equal to a difference of 2 squares, which is going to be x plus 1 into x minus 1. Therefore, f of x is equal to 3x plus 2 into x plus 1 into x minus 1, just like what we have. The next way is by long division. And I mean, I don't think all you need to go through the long division process once all you understand these two processes. In part C, determine the value or values of P for which the function has two real distinct roots, giving an answer in its simplest form. So first thing I'm thinking is discriminant. So I say for real and distinct roots. And distinct roots. B squared minus 4ac is greater than 0. Px squared plus 3x plus 2p. A is p, b is 3, c is 2p. Let b squared minus 4ac be greater than 0. 9 take away 4 2s are 8p squared be greater than 0. Minus 8p squared is greater than minus 9. Divide both sides by minus 8. Are going to get p squared is less than 9 over 8. And p is less than square root of 9, which is 3, divided by the square root of 8 is the square root of 4 by the square root of 2, which is 2 root 2. Right? That is it. 4 marks. Easy, easy. The easiest 4 marks of your life. All right. All right, that's it for number 1. So number 2, given that f of x is a quadratic, they're just asking us to complete the square, but the completed square version is not the usual a into x plus h squared plus k. The completed of the square version is a into x plus b squared plus c. So, 3x squared minus 9x plus 1. First, put the x terms in the brackets. 3x squared minus 9x, leave a big space, plus 1. Factorize out the coefficient of the x squared, x minus 3x. Now I'm going to add half of the coefficient of b, which is minus 3 over 2, to b squared, plus 1. And I need to take it away in the end, 3 into minus 3 over 2 squared. Whichever way all I want to complete the square, go ahead. This is now going to be 3, so this is supposed to be x squared inside. 3 into x take away 3 over 2 squared. Jumping on my calculator to work out the outside piece. 1 take away 3 into minus 3 over 2, close bracket, ogore. 1 take away 3 into minus 3 over 2, close brackets, squared, equals minus 23 and 4. Minus 23 over 4 is of the form a into x plus b squared plus c, where a is 3, b is minus 3 over 2, and the c is minus 23 over 4, are all elements of the real numbers. Part 2, state the coordinates of the minimum point of f of x. So we can say now, they didn't say hence, right? So if you want, you could go and differentiate, but we already did a piece of working that will help us get the answer for part 2. So I will say that our minimum point of f of x occurs at minus hk, but we do not have h and k. We have instead b and c. So instead of minus h, it will be minus b, comma, c, which is equal to, if b is negative 3 over 2, minus b going to be 3 over 2, and the C is minus 23 over 4. And we're good to go. Part B, alpha beta. The equation has roots alpha and beta. Find the value of 1 on alpha plus 1 on beta. Lick up thing. So 3x squared minus 6x minus 2 is equal to 0. A is 3. B is minus 6. C is minus 2. Alpha plus beta is minus b over a, which is minus 6 over 3, which is 2. And alpha beta is c over a, which is equal to minus 2 over 3. Consider 1 over alpha plus 1 over beta. I could get my LCM here. This is equal to beta plus alpha over alpha beta. And I put in the top as alpha plus beta over alpha beta. I know what alpha plus beta is. That's 2. And I know what alpha beta is. That's minus 2/3. This is 2 multiplied by minus 3 over 2. Bam, bam. And I'm going to get minus 3 to be 1 on alpha plus 1 over beta. Easy for marks. Part C. John's grandparents started a university fund for him at a bank with $4,000. The bank offered 2 options for interest. Option 1 is $240 per annum or per year, and option 2 is 5% of the current balance per year. So this is the interest we're talking about. Determine the sum of money in the university fund at the beginning of the 9th year for both options. So let me go with option 1 first, right? Option 1, which is going to be $240 per year or per annum. So John's grandparents started a university fund for him at a bank with $4,000. Now these things will line up in the form of an arithmetic progression because every year, grandma and grandpa putting in $240 in John bank account every year. So I can say that let A be equal to 4,000 and D will be equal to 240. I put in dollars and then as yet in the end I go put dollars. So we wanted to the sum of money in the university fund at the beginning of the 9th year. So the beginning of the 9th year is going to be the amount of money he has at the end of the 8th year. So if we kind of think about it in logical terms, right? If he starts the fund with 4,000 at the end of the first year, at the end of the first year, he's going to have 4,240. At the end of the next year, he will have 250 more. At the end of the next year, he will have 240 more, and so on. So the amount of money at the beginning of the second year is equal to the amount of money at the end of the first year. So let's write that down. So the sum of money at the beginning of year 9 is equal to the sum of money at the end of year 8. Cool? So I wouldn't say sum. I wouldn't say the amount. So I'll even out that second piece of solution. The amount of money. The amount of money at the beginning of the ninth year is equal to the amount of money at the end of year 8, which is going to be T sub 8, which is going to be, let me go T sub n. T sub n is equal to A plus n minus 1 by D. T sub 8 is equal to 4,000 plus 8 minus 1 by 240. Jump on the calculator. I'll put the dollar sign in the end. 4,000 plus 7 into 240. 5680. So that is how much money he has at the end of year 8 in his bank account. Then, there are two ways to do the next one, right? This last piece here. For option 2, we could go year by year by year by year by year and get how much money he has at the end of the year 8. Or we could apply the formula that says A is equal to P into 1 plus the rate raised to the power of n. And in this case, the rate is 5%. The principal is 4,000. So we go have 4,000 into 1 plus the rate is 5% to the power of 8, which is the number of years. This is equal to 1 plus 0.05 raised to the power 8 multiplied by 4,000 is 5909.82, and doing it the long way, I get 5909.84. This is 5909.82. And let me check back and see if the GP go work for this. 4,000 into 1 minus 0.05 to the power of 8 divided by 1 minus 0.05. Nah, the GP wouldn't work unless I mess up the formula. Right, so this is the compound interest formula. So that's it for number, that's it for number 2. Let's move on to number 3. Number 3, the equation of a circle is that determine the coordinates of the center. So we can either complete squares or bring it in the second form of the equation of a circle. So I'm going to say x squared, I put the x's next to the x's, minus 8x plus y squared minus 18y plus 93 is equal to 0. I want x squared minus 2 multiplied by something x plus y squared minus 2 multiplied by something y plus 93 is equal to 0. So what must go here to maintain the minus 8? A 4 had to go here to maintain the minus 8. And a 9 had to go here to maintain the minus 18. And a done is of the form x squared minus 2fx plus y squared minus 2gy plus c is equal to 0, where fg is the center, which is equal to 4, 9. And the radius is equal to the square root of f squared plus g squared minus c, which is equal to the square root of f squared plus g squared minus 93. Jump on the calculator and let me see what we get here. 16 plus 81. Take away 93. I get 4 Square root of 4 is 2 units. Now, if you want, you could say square root of 4 is plus or minus 2, and then say, well, you know, the radius is always positive, so therefore r is equal to 2. Oh, shucks. The first piece was determine the center of the circle. The next piece was find the length of the radius. So, what we can do, because we write down the statement there, for part 2, because we showed the working already, for part 2, you can say r is equal to 2 units. And we're done. Find the equation of the normal to the circle at the point 2, 8. All right, so a diagram could help us here, right? So let me draw it. It don't have to be correct. I have a circle at the center, and I have a tangent. Cool? Find a normal to the circle at the point 2, 8. A normal is perpendicular to a tangent. And a normal is parallel to the radius. So if I can calculate the gradient of the radius, I get the gradient of the normal, and I have a point on the normal. I good to go. So let A be 2, 8, and let the normal at A be N1, normal 1. You could name it anything. Let A be that, and let O be the center, which we calculated to be 4, 9. The gradient of OA is equal to y2 minus y1 over x2 minus x1. This is equal to, label your points, x1, y1, x2, y2, y2 minus y1 over x2 minus x1. 9 minus 8 is 1 over 2. And I put in brackets, this is the gradient of the radius. I can now say the gradient of n1 is equal to a half, and you're telling them why. Parallel lines have the same gradient, and it's saying n1 is parallel, this is the symbol for parallel, to OA. Equation of n1 using the point A, which is 2, 8. This is my x1 and y1. Is going to be y minus y1 is m into x minus x1. Y minus 8 is a half into x minus 2. Y is equal to a half x minus 1 plus 8. Y is equal to a half x plus 7 is of the form y is equal to mx plus c, where m is a gradient, is a half, and c is the y-intercept, which is equal to 7. Cool. Right, next question is the vectors question. The position vectors of 2 points A and B relative to an origin are such that OA, well, I writing over what OA is, yes? OA is equal to 3i minus j, and OB is equal to 5i minus 4j. Determine the unit vector AB. Now, the question should have said the unit vector in the direction of AB. All right? Because of how the question is stated, the unit vector AB is different from the vector AB. The vector AB will be represented with an arrow over the AB. So what I go in and do, yes, they tell me the name of the unit vector, but I go in and say let the unit vector in the direction of AB be u hat. U hat is equal to the vector AB over the size of the vector AB. Now my work is to calculate those two things. So I'm going to come on my working column here, and I'm going to say here, where is the scene? AB is AO plus OB, which is negative OA plus OB, which is negative 3I minus J plus 5I minus 4J. Add the I components. Minus 3 plus 5 is 2. And this becomes plus J minus 4J is minus 3J. One time, I can calculate the size of the vector AB is the square root of the I component squared plus the J component squared, which is 2 squared plus 3 squared. This is equal to 2 to the 4, 3 3s are 9, 9 and 4 is 13. So I get the square root of 13. If the straight line could, nice, square root of 13 units. So u hat is going to be 2I minus 3J divided by root 13. And what I'm going to do, and what everybody should do, isolate the I to be 2. I'm going to do it in 2 over square root of 13I. Take away 3 over square root of 13G. Next part. Determine the acute angle AOB in degrees to 1 decimal place. So this is our dot product now. So I'm gonna make some little transitions just to make life a bit easier for me. Let A be the vector OA. And let B be the vector OB. Now OA dot OB, if this is OA and this is OB, when I dot product the two vectors, that the angle I'm gonna be using inside. So I'm gonna say A dot B is mod A mod B cosine theta. I'm gonna change the vectors into vector column vector format, right? So let me just rearrange. Let OA be equal to common A, and I'm gonna let this be equal to 3 minus 1. Let OB be common B, and I'm letting this be equal to 5 minus 4. 3 minus 1, nice, good. So A dot B is going to be 3 minus 1 dotted with 5 minus 4 is equal to, from here, I can get the size of A, which is equal to the square root of 3 squared plus minus 1 squared, which is 9 and 1 is 10. I am going to simplify down with thirds even if it could. This one is going to be the square, the modulus of B is the square root of 5 squared plus 4 squared, 25 and 16, like 39? I don't know. Let me check and see. 25 plus 16 is 41. My bad. So this is equal to root 10 root 41 cosine theta. They did say that out the acute angle, right? So let me dot. I'm gonna get 3 multiplied by 5, which is 15. 3 by 5 plus minus 1 by minus 4 divided by root 410 is cosine theta. Theta is going to be cosine inverse of 5 3s are 15. 15 plus 4 is 19. Cos inverse of 19. I'm going to put it in 2 lines, yes? 19 over the square root of 410. 410. Which is equal to 19 over root 410. Cos inverse of the answer, 20.22 degrees to 2 decimal places. Part C, solve an identity. Solve an equation. Easy equation to solve. Nice domain they give us. Real nice domain. I'm gonna block it on my face. Real nice domain they give us. 2 sine squared theta is equal to 3 cosine theta. I'll recall that sine squared theta plus cos squared theta is equal to 1. So sine squared theta is 1 minus cos squared theta. 2 into 1 minus cos squared theta is 3 cos theta. Move everything on the right hand side. I'm going to get 0 is equal to, I'll get minus 2. Move it across, becomes plus 2. The plus 3 cos theta remains there. And the positive 2 comes across to be minus 2. This is the exact same thing as saying this is equal to 0. So once you can mental that, you could just write down this line one time. This could be factorized again, just like before when I mentioned. If you could see the quadratic here in terms of cosine theta, organize. If you want to make a substitution to visually see it, organize. So let's do the substitution. Let x be equal to cosine theta. I'm going to get 2x squared plus 3x minus 2 is equal to 0. I'll get 2x squared plus 4x minus x minus 2 is equal to 0. 2x into x plus 2 minus 1 into x plus 2 is equal to 0. Okay, x plus 2 into 2x minus 1 is 0. I get x is equal to minus 2, or x is equal to a half. Recall, x would have been cosine theta. So I'm going to get cosine theta is equal to minus 2. This has no solutions, and I tell them why. Because minus 1 is less than or equal to cosine theta is less than or equal to 1. Cosine theta takes values between minus 1 and 1, so cosine theta could never be minus 2. Or cosine theta is a half. We're diving into the quadrants. Cosine theta is positive, so my solutions are going to lie in quadrant 1 and in quadrant 4. Calculate principal value, which is cos inverse of a half. Now, cos inverse of a half going to be 30 degrees. Cos inverse of 0.5. They gave us the domain in degrees, so my calculator must also be in degrees. 60 degrees, sorry. In the first quadrant, theta is the principal value, which is equal to 60 degrees. In the fourth quadrant, theta is 360. Take away the principal value, which is 360. Take away 60, which is out of the domain. Solution. This around a little bit. Oh, God. Nice. Now, all the lines and things don't have to be perfectly straight like how I want mine to be. That's okay. My solution, theta is equal to 60 degrees alone for this particular domain. And finally, prove an identity for number 3. So the proof, taking the left-hand side, I'll have 1 over 1 minus sine x, take away 1 over 1 plus sine x. I go LCM down the place. I get 1 plus sine x, take away 1 minus sine x all over 1 minus sine x into 1 plus sine x. Well, the bottom is already a difference of 2 squares. And I see in the bottom looking to be cosine squared x. The top now going to be 1 minus 1 and sine x plus sine x are looking at 2 sine x on top divided by 1 minus sine squared x. I'll recall, this is my recall line. Sine squared x plus cos squared x is 1. Cos squared x is 1 minus sine squared x. And I'm also going to recall that sine x over cos x is equal to tan x. So I'm going to get 2 sine x over cos squared x. I'm not going to put equal sign, I'm going to put arrow. This is 2 sine x over, I don't know what the arrow day, 2 sine x over cos x multiplied by cos x. All I doing is I doing step by step, right? This is 2 sine x over cos x multiplied by 1 over cos x. Which is 2 tan x over cos x. Was it 2 tan x? It was 2 tan x over cos x, which is equal to the right-hand side. Close with proof Q, E, D. And that's it for number 3. All right, so number 4. A function given by y is equal to ax squared plus bx plus c has a gradient of 9 minus a half x. Now, that is not a gradient. That's a gradient function at a stationary value of 5. Now, the stationary value of 5 means that y is equal to 5. Determine the values of a, b, and c in the function. Okay. So, I'm going to let dy dx be equal to 9 minus a half x. Wala kulura. That dy dx. I'm going to say y is equal to ax squared plus bx plus c. I could say that dy dx from here is equal to 2ax plus b. Now, I have 2 separate but technically the same functions for dy dx. I'm going to let both of them be equal to each other. I'm going to let 2ax plus b be equal to minus a half x plus 9. Equate coefficients. my x coefficient, I'll have 2a is minus a half. I'll have a is equal to minus a half divided by 2 minus a quarter. My constant, I will get b is equal to 9. Now it have more than one way we could have done this. I could have integrated 9 minus a half x to get back y. And we'll do my business from there as well if I wanted to. Now the question says that how it has a gradient of 9 take away a half x at a stationary value of 5. So when y is equal to 5, what will I do? Thinking. So at a stationary point, dy dx is equal to 0. I will let the 9 take away a half x be equal to 0 because this is going to give me some substance. Minus a half x is minus 9 and x is equal to 18. So therefore, 18 comma 5 is the stationary, is the coordinate, is the stationary point. So now I'm going to say here is the scene. Substitute y is equal to 5. Well, let me go with x. X is 18 and y is equal to 5 into the function, because the question made reference to this being the function. So I will have 5 is equal to a x squared plus b x plus c. So c will be equal to, and we could work it out on the calculator, 5. When I move the minus a quarter, it becomes plus a quarter into 18 squared. When I move the 9 by 18, it becomes minus 9 into 18. I get minus 76. Therefore, I could do it down here. Y is equal to minus a quarter x squared plus 9x take away 76. Determine the nature of the stationary point is the next part. So we're going into the second differential, or you can go into a box plot if you want. Actually, we don't have to do none of that. Determine the nature of the stationary point. Since a is minus a quarter, the graph will have a maximum point. Simple. Simple. Cool? Because it is a quadratic. All right, so part B. Part B have a graph. Now, I will just sketch on not graph paper. A drone tracks the movement of an object on the ground. The following movements are recorded: velocity, 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 velocity. So they want a, from the graph I'm seeing here, they want a velocity time graph. So let me drop the axes. I am not going to have anything drawn to scale. Everything is going to be YOLO'd freehand. This is velocity in meters per second. Oops. And this is time in seconds. The following movements are recorded. It moves at a constant velocity of 4 meters per second for 5 seconds. All right, so 4 meters, that's where it started recording, right? So I'm gonna put 4 meters per second here, and it moves at a constant velocity for 5 seconds. So downstairs here gonna be 5 at the first part of the journey. So what I'm gonna do, I'm gonna let, and in a timing, I will label the parts of the journey O, A, B, C, and so on. Its velocity increases uniformly for 3 seconds to 10 meters per second. So my velocity increased to 10 meters per second. Come on, let me get a straight line here. Nice. To 10 meters per second. And it took, now I don't have a ruler, so bear with me. And it took 3 seconds for it to do this, so this is going to be 8 seconds. It moves at that velocity for 7 seconds, okay? 7 seconds going across here. And again, my diagram is not drawn to scale. 8 plus 7 is 15. It slows uniformly until it comes to rest after 4 seconds. So he goes slow down until his velocity reaches 0. 4 seconds after, so this is gonna be 19. So I don't know if it go help me, but I label in the O, A, B, C, and D. I don't know if it go help me. Let me see what the question asking us for. Calculate the distance traveled by the object in the second part of the journey. So the distance in a velocity time graph, and you had to write this down. The distance traveled is equal to the area under the graph. So because I say let on top, I can now say let this be A1, let this be A2, let this be A3, and let this be A4. If I wanted, I could have let this whole thing here, this whole trapezium be A3, if I wanted. But because I had them dotted lines coming down, I just put the whole thing to be the pieces to be A3 and A4. So the distance traveled in the second part of the journey is from A to B. So the distance traveled is going to be the area. It's going to be the area of A2, which is equal to 1/2 the sum of parallel sides. I know all of my thing perpendicular height, but it's perpendicular distance between them. Not all the time it's perpendicular height, because this is the perpendicular distance here, and that is not height. Technically, it's not height. Height is this way. So this is equal to 1/2. The sum of the parallel sides could be 4 plus 10. Perpendicular distance between them gonna be 3. 10 and 4 is 14. Half of 14 is 7. 7 by 3 is 21 meters, because the unit is in meters per second and time is in seconds. Determine the object's acceleration in the final part of the journey. Now they ask for acceleration. Again, you had to say this, the gradient of a velocity time graph is equal to acceleration. Gradient, it coming in to help me. Gradient of CD is equal to y2 minus y1 over x2 minus x1. I'm going back to basics. y2 minus y1, I actually going to input the coordinates for C up here to help me out. 15, 10, x1, y1 And this is d is going to be 19, 0, x2, y2, 0 minus 10, y2 minus y1 over 19 minus 15 minus 10 over 4, which is minus 5 over 2 meters per second squared. They never tell me anything about calculating deceleration. The deceleration is going to be 5 over 2, but the acceleration is going to be negative 5 over 2. And that's it for number 4. Number 4, that's it for number 4. All right, number 5. Consider a toy truck moving along a miniaturized racing course with an acceleration of, okay, so they gave us the acceleration. So A, in terms of t, you don't have to put the in terms of t, right? So because I go in and change how the information looks, I go say let A equal 9t squared plus 2t minus 1, where t is the time in seconds. Assume that the speed of the toy truck is measured in centimeters per second. Outline how an equation for speed of the truck would be found using the given equation for acceleration. Oh, so they just want the outline of how we're going to calculate speed. And we need to remember our nice good old acronym ZVA. Going down, we are differentiating. Going up, we are integrating. So if I have acceleration and I'm going up, I'll integrate to get velocity. So to outline it, I will say that v is equal to the integral of acceleration with respect to time. Now, if they want words, we could say that we need the velocity at a particular time in order to calculate the constant of integration, c, if they want us to have words into here, right? Part 2, find the speed of the truck at t is equal to 10 seconds. Okay, no scene. Now, do we need it to get velocity though? Acceleration of that with time. Assume that the speed of the toy truck is measured in that. Outline an equation for the speed of the truck will be found using the given equation for acceleration. Yeah, we'll have to integrate acceleration. So let me go ahead and do it now. V is equal to the integral of 9t squared plus 2t minus 1 with respect to t. V is equal to 9t cubed over 3 plus 2t squared over 2 minus t plus c, where c is a constant. Now, they only gave us the time. But we need to calculate c. So they need to give us another piece of information in order to calculate this constant c. Now, we will have to make an assumption here. We'll have to. We'll say, assume at rest v is 0 when t is 0. So I'll get let 0 is equal to 3t cubed plus t squared minus t plus c, and I get 0 is equal to c. So therefore, if the question does not give us information, we have to assume in order to calculate these things. If they didn't give us a specific velocity at a specific time, we have to assume that v is 0 when t is 0. Same thing goes for acceleration. Same thing goes for displacement. So therefore, v is equal to 3t cubed plus t squared minus t. At t is equal to 10 seconds, v is equal to 3 into 10 cubed plus 10 squared, take away 10, and v is equal to, jump on my calculator, 3 into 1,000 plus 100, take away 10, I get 3090 centimeters per second. The question said that I assume the speed of the truck is measured in centimeters per second. Find the distance covered by the truck between 5 and 10 seconds. Express your answer to the nearest whole number. All right. Now, some of you might just go into the integration here and get all your integral between 10 and 5 of v. No, because we don't know if any of these, any part of the graph is under the x-axis. We don't know. We're not sure. All right, if you want to draw the graph, you could, but we're not sure. So what we go do? Let me go ahead and get a function for displacement. So s is equal to the integral of v with respect to t. This is the integral of 3t cubed plus t squared minus t with respect to t. This is equal to 3t to the power 4 over 4 plus t cubed over 3 minus t squared over 2. I had to put plus k because I already used c above, where k is a constant. Again, they didn't give us no information, so we assume that s is 0 when t is 0. So, I mean, you don't have to go through no set of working. We go get 0 is equal to k. So, therefore, s is equal to 3t to the power 4 over 4. Take away t cubed over 3 minus t squared over 2. And we're good to go. Now, this is what we're going to do here. We're going to draw a table. We're going to draw a table catering for 5 seconds and 10 seconds. Now, this formula for displacement is going to be from O, or from the start. So, let me draw up a nice little table here. And let me put in 5 seconds to 10 seconds in it. Split it down the middle. We're going to have time, and we're going to have S from O. Time at 5 seconds, 6 seconds, 7 seconds, 8 seconds, 9 seconds, and 10 seconds. And we're going to be using we calculators a lot, right? So it will make sense when I start calculating 6, 7, 8 and stuff. At 5 seconds, I'll have 3/4 into 5 to the power 4. Take away a third into 5 cubed. Take away a half into 5 squared. So the reason I put it like this in my calculator is to make the future calculations a bit easier. I get, let me leave it like this. Actually, I will put the decimal equivalent and the fractional equivalent to illustrate something. So my fractional equivalent is going to be 4975 over 12. 49.75 over 12. Remember, this is going to be in centimeters, eh? And this is going to be 414.583. I just put in this here to show something. Now we're going to put time is equal to 6. So I'll delete the 5 and put a 6. I'll delete the 5, put a 6. I'll delete the 5 and put a 6. I'm going to check back something in the beginning. Good. I get 882. No scene. 882. Now what this means is between 5 seconds and 6 seconds, brother man moved forward. All right? He would have moved forward. How much he would have moved forward, it could just be the difference between those two numbers. That's how much he moved forward between 5 and 6 seconds. Now what we're looking for the case where he moved backward. If I get a smaller number, that means he moved backward. So we're going when t is equal to 7. Yes, I know it's a little cumbersome, but not all the time. Not all the time. It works out when you use your integration method. All right, 1661 and 11 twelves. 19943 on 12. 19943 over 12. So we're still moving forward. This is going to be 1661.916.917. All right, no scene. I'm still moving in one direction, forward direction. 8 now. Delete 8. Delete 8. All right, we're still moving forward. So this is going to be what? 8608 on 3. 8608 over 3. We're still moving forward. 9 seconds now. Delete 9. Delete 9. Delete 9. 4637. I'm going to put it as a fraction. 18549. 18549 over 4. 46. So we're still moving forward. I'll put it here. 4637.25. I forget to put what this number is. Let me check what that number is on our next calculator. So I do take out the function on my calculator. 8608 divided by 3. We get 2869.33. So we're still moving in a one forward direction. And replacing 9 with 10 now. Delete 10. Delete 10. Delete 10. We get 7,000. So we're still moving in a forwardly direction, right? So I'm going to put 21,350 over 3. So we're still moving in a forward direction. I can rub off the decimal equivalents because I know I'm moving in a forward direction. You all will see, and I will make mention of it in one of the papers. I can't remember which year it was. There was a question where the particle moved backwards and the integration technique would not have worked. You would have to integrate a piece, then get the modulus of a next piece, and then integrate the next piece of the function between some limits. Some bacchanal gonna happen. So this way is your foolproof way to make sure you cater for any piece of the graph that's underneath the x-axis. To get the distance traveled between 5 seconds and 10 seconds, just take away 21350, 21350 over 3. Take away 4975 on 12 to get 80425 on 12 or 6720 on 12. Well, I'll do that correct, right? 6720 on 12. Let me double check that day. 21350. Make sure my calculator. Well, let me just take away 4975 on 12 to get 6702. Change that the what? That's a decimal, right? To the nearest whole number, so 6702. So the distance traveled between 5 seconds and 10 seconds, just now, the distance covered by the truck between 5 and 10 seconds. So that will be including the 5 and the 10 seconds. So 5 seconds between 5 and the 10, between 5 and 10 seconds will be equal to 6702 centimeters to the nearest whole number. To the nearest whole number. Now, barring I didn't make any errors in my calculations, this is going to be correct. All right, let's see what the next question is. All right, part B, some simple integration questions. All right, so after much deliberation, I made a boo. If you all realize, I changed this to plus. I had it as minus in the beginning. Now I changed all the values in the table. My stance still remains to calculate at each second what happens to the particle. In this case, what happens to the truck? What happens to the truck? And the correct answer will be 7285 centimeters because I made this error here and I put a minus where a plus supposed to be. And again, these mistakes, they do happen. They do happen. So let me try and mitigate them as much as possible. All right, moving on to the next question. Some integrations. Simple integrals. Find the integral of 2x plus 3 squared dx. So let t be equal to 2x. Actually, this is the integral of 4x squared plus 3 to the 6 to the 12x plus 9 with respect to x, which is going to be 4x cubed over 3 plus 12x squared over 2 plus 9x plus c, where c is a constant. Simplifying it, I'll get 4x cubed over 3 plus 6x squared plus 9x plus c. Simple as I see my hair. Next, 5 cos 2x. Oh, I could do that one right here. 5 cos 2x is going to be minus 5 sine. No, I lie. When I integrate cosine, I get back sine. When I integrate sine, I get negative cosine. So this is going to be 5 sine 2x divided by 2 plus, I just put in our next thing, k, where k is a constant. C-O-N-S. All right. And part C. Part C could come downstairs here. If dy dx is that and y is 12 and x is that, find the equation of y in terms of x. We do something similar in the kinematics question before. So I can say that how There are plenty ways you could write down your statements. Let me write down the statements in this way. dy dx is equal to 6x minus 10. Integrate both sides with respect to x. The integral of dy dx with respect to x is equal to the integral of 6x minus 10 with respect to x. When I integrate dy dx, I get back y. So I'm going to have y is equal to 6x squared over 2. I don't want the arrow. 6x squared over 2 minus 10x plus, just to mix it up, I use c, I use k. I mean, is that completely separate question? Part 1 and part 2 would be related to each other, but part c is completely independent. So I could put back c, and I see where c is a constant. The say that all, well, determine that all y is 12 and x is 0. So I'm going to let y is 12 is 3 into 0 squared. Take away 10 into 0 plus c, and I get 12 is equal to c. So now I get y, I got y in terms of x. Y is equal to 3x squared take away 10x plus 12. And that looks like it for number 5. All right, number 6. The following stem and leaf diagram represents the scores out of 80 of students in an additional mathematics exam. Write the raw data set that was used to construct the diagram above. Now, it's kind of dodish. It's not really dodish, but they should have given us a key. They should have given us a legend. Now, granted that these scores are out of 80, I know that how it can be this tree, it cannot represent 300. It had to represent 30, making logical sense, right? But still, at the end of the day, they should have given us a key. Nevertheless, we know how to get the raw data from this. 30, 33, 37, 42, 44, 46, 47, 49, 51, 53, 53, 56. So I see 53 repeated itself twice, so that looking kind of meanish, moodish. 60, 67, 67. So I see in two modes, 71 and 79. So that's my raw data. Determine the following measures for the data set. First, they want the median. All right, I apologize for the sniffles. The median exam score is the middle. You could go first with last, first with last, first with last. So let me do that. Cheat a little bit. First 3 with the last 3. And first with last, then first with last, then first with last. First with last. First with last. 51 is Q2. So median exam score, I can say Q2 is equal to 51. The mean exam score, Lord, add up everything, right? All right, no scene. I'm not gonna do it right next to it here. This shouldn't take too much working. Mean x bar is equal to the sum of all of the frequencies divided by n, or it could be the sum of all the x values divided by n, which is equal to, I am gonna bother to write out all of that. I as a man gonna just add it up. 30. I mean, this is easy to add up. We will get 855 over how much scores we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17 scores. 855 over 17. We're going to leave it just so, right? Because they didn't want us to calculate it to decimal places. But if, just in case, 855 divided by 17, oh no, 85. 855 divided by 17 is 50.29. Is 855 it? 885. Oops, my bad. 885 divided by 17, 52.06. To 2 decimal places. The moral score or scores. The moral score or scores is going to be 53 and 67. Right, constructing the raw data, we could have noticed this from the raw data. All right, so next, given that the data, given that for the data set, the summation of x squared is that, and the summation of x is that, find the standard deviation of the set using the formula. So it's just a substitution game. So S is equal to the sigma x squared going to be 48999. Take away sigma x all squared, which is 885 squared over 17 all over 16. And it's the square root of all of this. It's not bad. This is equal to, and we could plug this in the calculator, but I will be smart about it now. Let me do it piece by piece. 48999 take away open bracket 885 squared over 17 divided by 16 raised to the power of a half. 13.53. To 2 decimal places. And just remember, this number means something. But see, if a student needed to score at least half the total marks possible to pass the exam, so I go say the pass mark could be is equal to at least 40, which means I just put in this out there, greater than or equal to 40. Determine the probability of a student failing the exam. Okay, so let me see who get less than 40. Three of them get less than 40. So let X be the probability of a student failing, or let F be the event that a student fails the exam. The probability of F will be the probability that a student fails is equal to 3 over 17. Giving an answer to 2 decimal places, okay. 0.18 to 2 decimal places. Now, I personally don't like to give probabilities as a decimal, but so be it. So be it. Part D, zoom out this here. Given that a randomly selected student passes the exam, what is the probability that the student scored over 60? So this is conditional probability. So let me get 2 events A randomly selected student passed the exam. Let P be the event that a student passes the exam. What's the probability that the student scored over 60? Let X be the event that the student scored over 60. We want the probability that the student scored over 60. Oh god, let me use P. Let me use Y. Because I will have probably P on the outside and a P on the inside. The probability that the student scored over 60, given that, no, with me given that, it could be the student it could be the student scored 60. It could be X given that Y. The probability that the student scored over 60 given that they passed the exam. This is equal to probability of X intersect Y over probability of Y. So what's the probability that the student would have scored would pass the exam and score over 60? Let me see how much students score over 60. Because if you score over 60, you automatically pass the exam. 1, 2, 3. 1, 2, 3, 4. 4 of them scored over 60. They never said inclusive of 60, right? So 4 of them scored over 60. So this is going to be 4 over 17 divided by how much students would have passed the exam. So if this is the students that fail, the students that pass going to be 1 take away 3 over 17, which is going to be 14 over 17. 1 take away 3 over 17. So we get 4 over 17. 4 over 17 divided by 14 over 17. 2 over 7. 0.29 to 2 decimal places. Based on the given stem and leaf, describe the distribution of the data set. Let's see, we can go back up and see how the stem and leaf look. All right, so the stem and leaf is looking like it's a little more bulge out from at the top, so it's positively skewed. So the stem and leaf describe the distribution of the data set. I could just say the data is positively skewed. All right, last one here. Your friend suggests that a bar graph or histogram could be used to represent the data. Advise your friend on which graph is better, giving one reason to support your answer. All right, so bar graphs, you will more use a bar graph for whole number data values or discrete data. Histograms can cater for values that are continuous. So we will go with a bar graph because this one here deals with whole number values. Advise your friend on which graph is better. A bar graph is better. As the data in this question in this question is discrete, whereas a histogram is used if the data is continuous. And that looks like it for number 6. And that's it for 2023. Next week, 2022.